Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna.
Hey, Dianna. Have you worked with medical products? I think you mentioned that you have.
Yes. I sort of grew up in medical products, I guess you could say.
Okay. Well, I've worked with a handful over the years, and in some extent, it's frustrating as all get out because in medical devices that are, one of the things they do is they say, all right, we got to sterilize it. So they put it in an autoclave, which is like super deadly to anything that's, if it's not straight metal, it's just going to destroy it. And they wanted me to help them figure out one time, how do we accelerate the damage caused by autoclaving? Like melt it in a blast furnace?
Now, this is when doctors are reusing something and they sterilize it in their office, right?
Yeah. And it's like, right. But that's not the worst, though. It's the ones that you run into a product, and it might be something that gets reused, but there's an element of the product that's single use. It's for one application or one patient at a time or whatever. And they just completely ignore reliability. It's a single use thing. How many of them don't work first time? Is that, you're going to call that quality or reliability? I just call it an expense. How about we solve that problem?
Or it's single use and it doesn't have any moving parts. Or there's a little it's software. We don't need to test reliability of software because there's nothing moving. Those are all things I have heard. Yes.
Yeah. But there's really two parts to this. One is, and for years and years and years, people have considered software as doesn't have a reliability problem. And then they try to reboot their Microsoft operating system 15 times to get it running again. That's a reliability problem. That's, and
nowadays too, there's a lot of software involved in emergency communication, emergency handling. So it's critical that it works right, not, beyond the home computer too.
Oh yeah, definitely. And, I remember one product, it was a monitoring system and it was used in the ICUs. I don't even know what that stands for, but critical conditions, and there's staffing and all kinds of stuff different than just going to a clinic. And the most common complaint they got for their product was all these alarms are going off saying it's not sensing what it's supposed to be sensing. And the machine didn't know whether got disconnected or got unplugged or if the patient passed away. They don't know. So they just go off with all these different klaxons all the time. So the thing's squawking at them all the time. So they ended up, I remember one they got back was down in their lab. The technician cut the wires off the speakers.
Oh no.
Because it was just making too much noise all the time. It was still working. It was doing everything it was supposed to be doing, but the timing was off, or the software went into a loop that it couldn't clear itself, or they just pulled it out. But that wasn't single use. That was a whole different. I could go on and on with these medical ones. Good grief.
Yeah.
But the single use stuff, I've run into ones where it's they're trying to show a shelf life. And so that was their reliability question.
Yeah.
And that makes sense. That was an opening for them to think through, how will this age just in a storage environment? And then they got into what kind of storage and how people typically stored these things and so on and so on. And then it was related to their initial design. When they got done with that, they said, oh, well, even if it's not been stored, if it's used right away, we still have a certain percentage that don't work right away. And he says, well, that's kind of the definition of reliability.
Yeah.
And
so it was coming out that people were trying to use and it wasn't working.
Yeah. And then they would have to open another package and, prep another unit of it or whatever and use it and go again. And he says, we typically call that an out of box, or, I tried to use infant mortality, but the medical guys really kind of cringed at that
one. Yeah, that one threw me for a loop when I first heard it too. I'm like, what?
Yeah.
Okay, but anyway.
But I said, out of box or time zero failures. But it's not really time zero because you manufactured it and put it in some shipping container or box and transported it, and then it got used.
That's right.
In between this time when you started assembly of this material, of this unit, and when it got to be used, it has a lot of opportunity to fail. And so the duration is not technically zero. It's, it starts when that defect was introduced into your product at some point that causes it not to work. And they went, oh, I never thought of it that way. And it's like, yeah, a lot of things fail, not in use. And I remember a presentation years and years ago of somebody from the auto industry saying that the typical home-based car or vehicle sits idle like 24 and a half hours a day or something on average. Not around here. People commute 2 hours, it seems like. But
recently I've commuted 0.
Yeah.
So I'm skewing the results.
Well, there's a lot of us doing that now. It's
yes.
But it's the people were thinking of reliability as the door opening and closing so many times. Well, if you're not getting in your car and going anywhere, that door doesn't move. But the weight of that door, if it's not secured properly, will start to creep and bend. And so they were looking at all the failure mechanisms and failure modes of when you're not using the vehicle. And, paint degrading, oils coming apart, oxidizing, lubricants seeping out. All kinds of stuff happen when it's not being used. And that kind of opened me up to when I get to these single-use products as well. Besides the manufacturing process and all of the defects that can be latent defects get introduced there, let's assume you got that. What about your packaging and unpackaging and transport and just storage conditions? What could go wrong there? And it's not like it's moving. It's not like it's wearing out. But if it's software and it's a little bit colder than it normally is, electrons don't move as quick in copper when it's cold, or quicker. They change speed. So your signaling could be off, and that could affect your product. And that's right at point of use. It could be a problem. But it also could be that parts of your circuitry corroded, or parts of your system were damaged, during transport and were frayed, and then they get applied to voltage and then they fail.
Or if you have a sterile product, your sterile barrier might break.
Yep.
Or just peel apart, and then you don't have a sterile product anymore.
Yep.
And then in medical devices too, you might, those single-use products, there might be a patient all prepped in the operating room with the doctors and nurses there, and they're ready to go, and they were prepping the product, and now they have to delay everything, the procedure.
Yep.
And that can get into some difficult and risky situations too. So it's not okay sometimes.
Yeah. And single use doesn't mean cheap. A lot of times it might be unique in a device or probe or sensor or whatever it is. But if it's not ready to go, you don't always have, I'll just get another syringe. You just used the last of the medicine you were going to use in this thing. Now you're done. So there's some redundancies. I've seen that in plenty of applications where with single-use things, they will tend to have a backup or another procedure of some sort. But some of that is, I ran into this early on, and I think it's changing, is that the reliability of the products, especially single-use stuff, as long as it doesn't harm the patient. And so, like lack of being sterile or being contaminated is going to pose a threat to a patient. But if it just doesn't work, like they can't actuate something and the button doesn't turn on or doesn't engage with whatever system you're using it with, it doesn't harm the patient. The delays that it causes may lead to that, but the device itself doesn't. And what I've run into is that the people working on those kinds of products is we'll just use the second one. And then they're thinking, well, we sell two of them now. Like,
in one package, they sell two.
Yeah. Or they just have, sell them by the case and, well, you just have another one available and we have more sales. And I'm like,
well,
you do that often enough, you're going to, it's like yield at the end of your production line. If you've got 50% yield, that's not a good business model in a lot of cases.
No. And even, the people that work in healthcare, they want, just like any of us, and especially in that hyper environment, they want to be able to open a product and use it to help someone, not fiddle around into the stock room.
Yeah.
Because there's a whole bunch of procedures they have to go through to get that. So yeah, it's a lot more than just open up another package. It's a real headache, and it ties things up. So that I'm glad that I think for the most part, we're moving away from that kind of thinking and thinking more about the reliability of these single-use products.
All right. So let's say you're working on something. Let's use just like a syringe. It's a single-use item, and it has to carry has a certain feature or certain kinds of medicine it applies and all this kind of criteria. But just to visualize a product that's a single-use thing. I mean, an FMEA could cover all the things like the plunger doesn't engage, or it leaks, or it doesn't provide the right dose or is expected dose, and all these different things. And that's a moving part. And we can go to the lab and we can test a bunch of them. We can do mechanical drawings and look at different tolerancing and dimensions and seals and properties of that. Yet we still need to think of like that rubber seal that's on there. How does that age? Will that leak over time? And because it's not lubricated, or it is, how does that lubrication behave? Then you get into the software type stuff where it's maybe a patch or a sensor or something that's transmitting some information when it's applied and it's got a limited usage time frame and all these things. The storage, to me, jumps out as the big thing. But the first thing is, how do you set a reliability goal when you don't have a duration? For example, it's just pull out of the package and use it. And I think we talked about it earlier. It's like, well, what's the success rate? How often do they actually work when you first use it under different storage and sets of conditions that they have? Time might be 0, but that still counts.
Yeah, that's right.
But it changes. It's not looking for wear out mechanisms per se, although storage is a lot of wear out type things play there. I don't know. I run into it. It's very much like any other product. I just kind of go at it going, what are all the ways that it'll change and not work?
Yeah, and you can have corrosion and storage.
Oh, yeah.
We talked about that in a previous episode. Just corrosion takes time is what is, I think, what you had said.
Yep.
And yeah, so it's the storage and getting it to people where things could happen that are bad, or even when they're starting to use it, or if they're prepping it, there's certain forces that they're pushing or pulling with. And that can all follow a reliability kind of requirement and program too. That even if it's a minimum pull strength, maybe they're pulling a catheter out of somebody's body, and it's got to have a certain pull strength, or it's going to break off into someone's body.
Yeah.
You can design that with a factor of safety and look at the reliability of that. And as far as, it's been sitting in someone's body for 2 weeks. So there's those kind of use reliability things, even though it's a single-use product. Just the duration of its use over time in its environment.
Yep. Oh, it's one of the things I really don't like about working with medical products and devices is how it's used. I get squeamish around all that stuff. It's like, I can help you with the spring tension and force over here, but don't tell me where it's used or how it's used.
I was a quality engineer on a project, so I'm like the independent voice of the customer, and I'm working with the cross-functional team, and I'm trying to learn about this product. And I asked for information from the nurses. They sent me all sorts of training videos and stuff. And my kid, who was in elementary school at the time, came around the corner. I was like, "Hey, mommy, what are you doing?" And she's like, "Ew, what is that?" I'm like, "Yeah,
Yeah.
I know." So, yeah, that is something, I couldn't do that stuff, but I appreciate being able to help the people that can.
Oh yeah. Yeah. No, I get that. Yeah.
So I can, I can watch a video if it helps me better understand something. I'll get past it, but yeah.
You're better off than I am. I was like, I don't want to watch a video of you doing this knee surgery or eye surgery or heart. I worked with a lot of surgery type stuff.
Oh yeah.
I just don't want to see how this is used. I get it. But it's okay.
You did do one of those dummies, right? The plastic dummies.
Even that's bad enough
show
for
me on that.
Yeah.
Oh,
give me a schematic, kind of vague description. Well, this is used in a hospital. Okay, that's close enough.
Yeah.
But it's, I've run into people with single-use stuff that, one was, I'm trying to remember what the nature of the product was. It was so long ago. But anyway, they actually tracked how many times people would say, "Hey, this is bad." It was expensive enough that the people using their product, and it wasn't a medical product. It was a home use product for a medical condition. I think it had something to do with, it's not an EpiPen, but it was, I'm drawing a complete blank on it. But anyway, they made gazillions of them, and they were very inexpensive, or not inexpensive, but they were expensive enough that people complained when they didn't work. And it was an inconvenient for the person trying to use it. And it was like a treatment of asthma or something like that. So it needed to work.
Yeah.
And so they would collect all these ones that came back, and they did very little failure analysis. It says, about 20% don't work.
Oh, that's not good.
And I'm like, really? Why are you okay with this? And it turned out that their way of tracking their failure rates was they would say, how many are we shipping this month? So let's say in January, we ship 1,000 units, using just random numbers here. And then in January, in that exact same month, how many did we get back? How many people complained? Oh, we got 150 back. But in June, they would ship 10,000 units, and they would get a very low return rate because they'd only been shipping a much lower number for the last couple of months. So the number of units that were available to be used was much lower, but they had ramped up the amount. I think it was allergies because it was very seasonal, and they ramped up and shipped a gazillion of them. But the previous month, they only shipped a couple hundred. And so the number that came back was very low. And so every year they thought, oh, we got it solved. And they didn't do anything.
Oh, wow.
And then in August and September, into the fall, their failure rates would skyrocket because now they're shipping a lot less, but they had the population available was much, much higher.
Right.
And I'm like, come on, you I was speechless. What are you tracking this? Who put this in place? Yeah. Once they got past that, then it was, we actually need to do failure analysis. Yes. You actually, if you're getting failures in the field that is causing your customers to actually take the time to send it back to you, they're trying to tell you something, that it's not working quite right. And their profit margin was such that they were making money hand over fist, so that it just never dawned on them that they needed to do something. And I said, are you losing market share? How'd you know that?
Yeah.
Come on.
Yeah, eventually it gets to
Yeah.
the pockets, right?
Yeah.
But there's a responsibility there when you're providing these products to people, and yeah, you need to follow through. If they're, like you said, if they're complaining, you need to follow through and figure out what's wrong.
Yep.
And at least look at it and assess it, and then you can make different decisions based on that. But
I do remember the quality engineer. It was the person that got me involved to come visit the company and look at what she was seeing going on in the company. I think she got it, but by the time she get her case together, going, hey, we need to fix these things. They're not shipping. They're the shipping cycle and the way their metrics were. Well, it's getting better. We're not going to worry about it. We're going to fund that. Okay. But anyway, and she was like, well, they've been measuring it that way forever, and that's what they want to do. And like, okay. But so it was a heart to heart with a few senior folks there going, really? But I don't know. I've run into people that, if you're doing a rocket engine and it's a single use rocket engine, although now with rockets that land and get refurbished and launched again, this is not as true anymore. But single use rocket stages, for example, they're big and expensive, and you do a lot of testing of systems and ground burns and all these other things. And it's in aircraft wings, while they're not single use, we don't test hundreds of them. We test one, kind of thing. Yet there's tons of things that can be done to understand the durability and robustness and reliability of those systems. Now, single use units, whether it's software related or a syringe or a single use sensor, for example, they still have to work. And all of the tools and techniques that we use for reliability still apply. And so I don't really see, other than the mindset, as being the big issue.
I think that's exactly what it is. It's just a different mindset. That there was just over the summer, there was a reliability engineer telling me that he had to let people know that we do reliability testing on software. That this was still
it was a new
it's still a thing that he still had to coach people about. And yeah, I think you're right. I think it's just a mindset. But I think once you see it, then you can't unsee it.
Yeah. Yeah. And to me, it boils down to is if it doesn't work, I don't care whether you call it a quality issue or out of box issue or a reliability issue or anything else, it still causes consternation and costs to your customers in one form or another. And if they report it to you, that causes costs in the call center and returns and just dealing with customer complaints, and all those factors build into it. So it's, in my mind, it's still something's not working. That's a problem. And so it's something to be solved. And yet the good thing is that all of the standard tools that we use and approaches that we use, from design practices and risk assessments like FMEA and HALT kinds of approaches to modeling and evaluations and testing, they all still apply. And it's just that it either works or it doesn't. It doesn't have a work over 20 years kind of criteria.
Mm-hmm.
So if you really like doing long-term accelerated testing, then hopefully you have a good long storage period for your product. You can work on that. It's just different stresses. It's same techniques, different applications, environments, stresses. So anyway, I think we kind of came all around full circle going, it's just like anything else.
Yeah. Well, I guess so. Yeah. And, but it's good to just put that out there.
Oh, yeah. Yeah. So if you're using a single use product, do you have a good, robust reliability program for it? And, if not, hopefully this sparks some conversation in your organization. let us know how it goes. And if you've got questions, if you're faced with a single-use thing or have any reliability, quality, risk type questions for us, let us know. Dianna and I certainly, and along with the other hosts, certainly appreciate hearing from you. And you can do that over at accendoreliability.com/go/SOR. And Dianna and I and the other hosts are available through LinkedIn or through our About pages. So plenty of ways for you to get in touch with us. And hopefully it's not a single contact. It's get in touch with us often.
Yeah, it's fun hearing from people and getting to learn about what they do and how they approach reliability in their jobs. It's really interesting.
It is. It very much is. All right. Well, thanks so much, Dianna. We'll talk to you again soon.
Thanks, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.